one variable at a time. So this lecture is almost entirely brand new. This was the point at which things, in the last few semesters, I felt like folks struggled more than they needed to, so I spent a bunch of time this summer trying to do better. So this is 80 slides. It's going to take us like 6 weeks to get through. So when you see the slide count, don't panic, right? It's all sort of one set of concepts, but I don't expect that we're going to get through all of this today. So um, I have examples in here from real data sets, and this is the one instance in which I'm going to have pieces of code and pieces of output inside the slide deck. Normally what I do is I create a separate handout that has the syntax and the output and annotations, and we go over it. Because I'm going to show you how to actually generate these results in a video, I didn't do both. So you will get a chance to see, literally see, if you watch the videos, how I got the output that I did to describe the variables that are in this analysis. So, all right, away we go. Univariate. So two parts here. How do we describe variables within a given sample? So for one set of data, how do we summarize their salient characteristics? And then the second half, how do we try to extrapolate what we know about that sample and how that would translate to what we think we might know about the population the sample came from. So just describing what's there and then trying to make an inference to where it came from. Two big things here. So univariate, that's this unit here. The term univariate, one variable. That's what it means. So we're dealing with just one variable at a time so far. The next unit will be bivariate. Can you guess what bivariate means? Yeah, hand signals is fine. Yeah, two variables. Yeah, after that, it doesn't go to trivariate or quadvariate. It just goes to multivariate. So just one, two, or a lot. So yes, univariate today for the next few weeks, bivariate after that. So given our two kinds of variables, categorical or quantitative, there's different strategies behind each for how you would summarize that variable across a group of people. So when I say a sample, I'm thinking in the context of responses from individual people, and I'll say people, but just know that that could be anything. So if you're interested in things that affect teachers, like the teachers might be the people in your world. If you're interested in things that affect students, the students might be the people. I've taught students who did animal models, so their people were actually rats or mice, for instance. Over in psychology at the University of Nebraska, they used to get rats addicted to like meth and nicotine and fun stuff like that and see how long it took before they died. You know, so those were the people in that person's world. So, does anyone have research interests or is in a program where that would not hold? Can you think of it? Is anyone thinking, that doesn't apply to me? No? Okay, so people, right? Surveys, samples of people. We're going to stick with that. So if you're trying to summarize variables that are categorical, where you have kinds and not amounts, all you need to know is just the frequency of response to each possible category. If you have a binary variable, meaning there's only two options, if you know the frequency of people who answered a 1, then you have to know the frequency of people who answered a 0 based on your total sample size. If you have 3 categories, you got to know 2 of them and you can deduce the third. So for summarizing those kinds of variables, it's pretty straightforward. You have the frequency of responses. It usually helps to convey that as a percentage instead, so that it's out of 100. That way people can understand the scale without referring to the exact sample size that you have. You can depict those results using what's known as a frequency plot or a bar graph, and adding labels to the numbers will make sure that people can actually understand what they're looking at. So for instance, I have a data set for this example that is a subset of the General Social Survey from 2012. It's the data set that is used in the Mitchell Stata book that was optional for you guys. I borrowed it because it has a bunch of different kinds of variables for our purposes. So one of the variables they collected was a 5-category variable for marital status. And what you're looking at here is SAS code and output to summarize that variable. So on the left here, SAS commands all start with the word proc. That stands for procedure. Procedure this, procedure that. Freq stands for frequencies. So any kind of information that has to do with the frequency of response for each category, you get with proc-freq. In SAS, you have to tell it what data set you're referring to. In the videos, I'll show you how you know what that is. Data sets have 2 parts to their name. Where it is, which is this work thing here, is a location that SAS understands where it is, and the name of it, which is example 1. Table is, okay, which variables do you want me to try and summarize for you? Which tables do you want? And the name of the variable, the column name, is marital. So note this is lowercase. One fun difference between SAS and Stata, SAS is not case sensitive. I could type marital in lowercase, marital in uppercase, or title case, and it don't care. Stata cares. Stata is case sensitive. So you have to know in Stata exactly what your variable is called. For that reason, when programs create data sets in Stata, they often convert everything to lowercase just to make it easier. So just as a side note here, to close procedures in SAS, we have the term run. It's like, I'd like this, run. Now you would think that just highlighting the code and pushing some button would be run enough, but run is like a completer. The way I think of it is as the please at the end of the sentence that I demand from my 5-year-old. Like, Mommy, can I have some more milk? Oh, I can't hear you. Mommy, can I have some more milk, please? Oh, now I hear you. Of course you may, sweetheart. So it's like, I'd like the frequencies for the variable called marital, please. And then it goes. And what pops up in another window is a table that looks like this. So the 3 parts of a variable that I talked about earlier are demonstrated here. The name of the column is marital. Across the top of this table, can you all see my pink mouse, by the way? Okay, yeah, I have a giant monitor, and so my mouse is like this big on it because I kept losing it, but hopefully it's big enough to where you could find it. This little phrase right here, marital 5-category marital status, that's the label. So that's just a piece of information that is attached to the column. That way you have more you know where it came from. Down this side, these are the labels for the values within the variable. So there's a lot of V's here. There's the variable, which is like the set of information, the values within a variable. This is a nominal variable because I have categories. I have given the categories numbers just to help with the data entry, 1, 2, 3, 4, 5, but the numbers aren't numbers. The way that they are assigned is described by these value labels. And so within the table, for each kind, it gives me the frequency. So there is 734 people total, I think. Oh, nope, take that back. There's 1,974 people in this data set. This is how many are in each category. And then here's the percentage. So without knowing how many people total that I have, it's hard to interpret this first column. It's a lot easier to interpret the second column, the percentage. So a little under half of the sample is married. The other 55% of the people are scattered across these categories. The last 2 columns are cumulative, either the number of frequencies altogether or the number of the percentage altogether. For nominal variables where there's no real ordering, these last 2 columns are useless. They're only helpful for variables where they have some kind of natural ordering to them. Okay, with me so far? Stata folks, looks a lot similar, however, less typing. So in Stata, the command that summarizes categorical variables is called tabulate. Like I would like to table it. The variable is marital. You don't have to say please to Stata. It's fine to just run it as it is. And in Stata, you can only have one data set open at a time. So you don't have to tell it which data set you're asking this information to come from. I think in the latest version of Stata, they've changed that to some extent, but in old school Stata, you don't have to specify it. And so if you only have one data set open, it's not ambiguous. It's straightforward as to how it's working. The output for Stata looks older. So it looks like plain text. It is what it is. SAS output defaults to HTML, which looks a little nicer. Question, what does marital mean in the Stata example? Marital is the name of the column that we are asking for a tabular summary of. So it's the variable's name in each case. So marital is up here in SAS, and it's here in Stata. Now the colors, I know the colors look arbitrary to you, but you're going to get used to seeing them and they will help you. So in both programs, commands that are recognized commands in SAS or Stata are going to be blue. So here in Stata, tabulate is this navy blue color, procfreak is this navy blue color. In SAS, the lighter blue is used as options within a command. Anything that is black is text that is specific to the dataset that you're working with, either the name of the column or the name of the dataset itself. So yes, marital means the same thing in SAS. So for this example, I will literally show you the exact same thing and what it would look like in both programs. And in the videos, I will run these things in front of you so you can see how you actually go in and generate this information for yourself. So in your homework, this is the kind of task that I'm going to ask you to do. Recognize which procedure is going to be useful to give you the information you're looking for. Figure out what you need to change to customize it to work for the homework data set. So what column, variable, and what is the name of the data. So those are the things that you would need to change. Any other options that you would need to select, I will have an example for as well. Okay, so Stata's output looks, other than a little bit of difference in the formatting, it looks pretty much the same. And I have highlighted this 45.49 to make a point. Another area of confusion in homework. So for your first homework, I will ask you to generate these kinds of summaries, frequencies and percentages. The way that I want you to enter the percentages, though, is as a proportion. So rather than proportions out of 1. Can you scratch off these 2 zeros right here? That's a typo. I'll fix the slides and repost those later, but this shouldn't be out of 100. It should be out of 1. So this percentage that's 45.59, when you enter it as homework, should be entered as 0.4559. Why? Because for all of the inferences about that number, so analyses regarding that number, it's on the 0 to 1 scale. So just to be internally consistent with how SAS is treating it. Just keep that in mind. Okay, so other questions? Are you still with me? Do we need to like take a minute and be like, yeah, just take a moment. When I used to teach on campus, I used to sometimes make the students literally get out of their chairs and like stretch when I could see like the energy level of the room starting to stink. So I'm not above doing that if that's what it takes. The good news is that class is only an hour and 15 minutes. You can stretch and listen. Absolutely. Yeah, so I was going to say this before and I forgot. You'll notice that my slides are just like packed full of stuff, right? These are not the undergrad slides where there's like 3 words on there and there's room for you to take notes. The reason that I do it this way is so that you can sit back and listen. I hope that most of what I'm saying is on the slides for your reference, and you can focus your energy on just processing the information and not trying to scribble it all down. So I am totally fine if you want to do some yoga and listen. You could also be working on your nails and listening. Um, the last faculty meeting of the spring, I will tell you, I gave myself a manicure while the dean was talking, and I thought it was the best use of time ever. So yeah, whatever it takes, to multitask. My husband once had a student who brought her knitting to stats class. She was like knitting in the background. She made him a bear at the end of the semester that had a matrix equation like knitted on its shirt. So that was her contribution to the class. So whatever it takes to keep yourself calm and well stretched, flexible. That's the word I want. Pictures. So if you're giving a presentation and you want to describe data, tables of numbers are very bad, right? You've all been at talks where they put up tables of numbers and the numbers are like in 9-point font, and people say, "Oh, I know there's a lot of numbers here, so let me tell you where to look." And it's like, if you knew that, why didn't you do something about it before you gave the talk? So yeah, don't give them this table, right? Give them this picture. This is what's known as a frequency plot or a bar graph. It gives you the frequency or the percent of the people in each category. I like percentages better, and so I asked it to make one that looks like this. So this plot is from SAS. To get this, I added something to the table line. So on the previous slide, I just asked for the table and a semicolon. Semicolon finishes the thought, the command for each of these things in SAS. Here, I added an option. So after a slash is how you tell it options, plots, frequency plot. Type is bar, scale is percent. And it made me this picture. So this is a lot easier to show that a whole chunk of the people are married and that there's relatively fewer people in each of the other categories. The order of the categories at the bottom will correspond to the order of the variable. So it goes 1, 2, 3, 4, 5 because that's the way that I coded it. If you wanted to put them in a different order, the easiest way to do that is to change the numbering system so that it's in the order in which you want it to go instead. So you'd make a new variable and tell it to reorder them in that. We'll talk more about that later. In Stata, it's a separate command to make a picture. It's called histogram. Stata's options happen after a comma instead of a slash, but these are the options that tell it to make a picture that looks just like that. So we want every value out of 5 possible. We want it to use the labels, and in the Stata picture, there was not enough room on the x-axis, this part, to show all the labels, so they were staggered so that you could see them all a little bit better. All right, so good with this so far? All right, yeah, not bad. For your homework, you're not making pictures. You're going to be entering information and interpreting it, but I want you to know how to make pictures because in life, it's a very useful skill. So for quantitative variables, things have to change. So if you're dealing with numbers, whether or not they have a boundary is irrelevant for the focus of this conversation. If you have many possible values, that kind of frequency table and corresponding plot is not going to be very useful. So one of the values, the variables that's in this data set, for instance, is personally reported income in thousands. And rather than having people enter exact numbers, I think they had them choose from a bunch of categories, but it's enough categories to where it looks like numbers. And so if I were to make a frequency plot of income, it looks like this. So this is not really helpful. It's just listing every unique value and the number of people that gave it, but it doesn't understand that the distances between these numbers mean something. I can't easily stare at this table and get a sense of sort of what the average income is, or how many people are in one section of a distribution versus another. So for quantitative variables, these kinds of tables and plots where you have a number for each exact category are not going to be useful. So this is the plot that goes with that. And so the distances between these things are not equal. So the x-axis is not terribly useful. If you want to make a picture in Excel, to the best of my knowledge, you are stuck with this kind of picture, this less helpful kind. What would be more useful is something that's called a histogram. And that is where you can lump values of the quantitative variable together. So you make convenient lumps that you can use to summarize, and the lumps understand how far apart the categories are. So in SAS, for instance, I looked at this variable and I know that the highest value is, I think, around 68, so $68,000, and the lowest value is just above zero. So I'm going to ask it to make a picture, a histogram, that goes from 0 to 70 in increments of 5. And here's the code that does the same thing in Stata. So this is a different procedure in SAS, proc univariate. Univariate gives you all kinds of information about a variable, and it makes all kinds of pictures. So the structure of the code in SAS is very similar. What do I want to do? Proc univariate. What data set do I want to use? Data equals this one still. Instead of table, it's var, where var means variable. So which columns do you want to do something to? And the column is called income. I want to make a picture of income that's a histogram, and I want it to lump all the values into $5,000 increments and plot it starting at 0 and going up to 70. That's what I'm trying to tell it to do. It looks like this. So if I look at this picture right here, it looks like most of the people in the sample don't make very much money. That's a very different conclusion than if I tried to plot every single value, right? If I just stare at where the bulk of the data is on this frequency plot, it looks like most of the people make a lot of money. That's because these numbers are not arranged in a way that pays attention to how far apart they are. So histograms are more useful. And in making these sorts of pictures, you can decide how far you want it to stretch and how many bins you need. The software can do that for you, but you can also control that to make it a little more generalizable. So the x-axis gives you the bins, 0 to 70 by 5 is what I said, and then the y-axis gives you the percentage in each. So this summarizes the distribution of this variable, how it is observed within the sample of persons, this 1900 and some odd persons. So pictures are worth 1,000 words. Getting used to making pictures will help your cause. All right, how we doing?
Pretty good. Can you flip back to the histogram code for the categorical variable for Stata?
Yep.
So this is the quant, and then...
Yeah, it's histogram either way.
Yep.
So in most programs, Stata included, there's more than one way to do something. And my approach in trying to figure out how to do stuff, so I'm a big SAS user, but I picked up enough Stata to be conversant. And I literally I Google, Stata histogram or Stata frequency plot, and then something comes up and it works. So that is to say, the first thing that I found that worked is histogram, which covers both kinds of pictures, either the plot of each individual level or the summary. There's probably other ones that you could use too. Okay. Does that answer your question?
Absolutely. I was just curious how the syntax differed.
So it's histogram is the command, what variable you want it for, and then after the comma are the various options. And so in this instance, I'm telling it that it's discrete, meaning that it is a variable that only has integers. And I want it to show percent instead of frequency. And the x-axis is what this term here refers to. And honestly, I found this and played around with it until it worked. But what I think this means is that I want to show each of the categories, and there's 5 total. I want it to use value labels. And then the alternate made it so that it was like 1, 2, 3, 4, 5, so that the letters weren't all smushed together. So,
Great, thank you.
sure. Other question. Um, should the midpoint always start at 0? When is that okay if it's at 0 or not at 0? Ha, great questions. Um, reasonable people would disagree. So I think whether or not you start at 0 depends on what the variable means. So a variable like money, like 0 is a number that means something. If you have a scale that's like the suicidality scale from a little while ago, if you have a scale that is full of 10 items, each measured on an ordinal set of options of 1 to 4, the lowest scale value you could have is 10, and the highest scale value you can have is 40. So putting that variable on a plot that starts at 0 when that's not even possible is probably not helpful. I would show the full range of the variable 10 to 40 so that you could show where people fall. I think where you get into trouble is when you have a very narrow range shown and it looks like it's a big deal. So if you have this variable that should be 10 to 40 possible, and most of your people are within like 20 to 25 and that's all you show, then it could look like you have a lot of variability, but if you just narrow in on that part. Whereas if you showed the full range and there were no people on the extremes, you would realize that, okay, no, most of the people are in the middle. So it's easy to be deceptive with plots, accidentally or on purpose, but I think your axes should always be informed by the possible range of the variable that you want to show and sort of what is a reasonable approximation to that. So I don't know if that answers the question, but 0 isn't always relevant is what I would say. When it is, show it. All right, so it's 1:44 by my laptop clock. That means we're done for today. Any other questions or comments before we wrap up? One? Go ahead.
Will you have office hours today?
Yes, I do.
Okay.
3:15 to 4:45, I will be here.
So we don't have to set up an appointment. We can just like,
Yeah, the idea is that it's come one, come all. If I'm currently talking to someone, I might send you a note that says, "Can you give me a minute?" But usually, what has happened, and it's worked okay, is that I just admit everybody. And then if you want my attention, just say in the chat window, like if I'm talking to someone else, and I'll just get to each person as they're available. And if you're working on something, you can stay in the Zoom session and work on it until you get stuck again, and then you can come back in line.
okay, thank you.
So, sure, if you want to arrange a time to meet with me individually, then we can do that too. But office hours are for everybody and you don't need an appointment.
Uh,
Okay. Anything else before we sign off? Okay, it is Thursday, which means have a good weekend. Stay safe, stay well, and I will see you next week.
You too. Thank you.
Thank you.